we've spoken on one previous occasion, and you mentioned the need to refreeze the Arctic. I think that was the phrase that was used. Can you tell me, how do we go about that, and why is it necessary, and is it possible?
Let's go back to the last two questions first.
Okay.
I'm going to say not only is it possible, it has to be done. If we're going to have a future on this planet, it has to be done. And to explain that, I have to say that we've got a bunch of tipping points, climate change tipping points around the planet. And a group of people, Tim Lenton in Britain is one of them, have been challenging the world to think about these tipping points. And now the Intergovernmental Panel on Climate Change, AR6 report, which came out at the end of August, says expressly that ice on land is now beginning to melt irreversibly. Sea levels will continue to rise, not only for the next tens of years, the next hundreds of years, out to 1,000 years, and will eventually reach 20 meters for the whole planet, sea level rise, which changes everything that we know about the world. Well before we get to that point, the global economy will no longer be a global economy. So the beginning point of all of that, the first tipping point to go, is the Arctic Circle region. And what has been happening, particularly over the last 30 years, and measured by my very good colleague Peter Wadhams, is the faster and faster loss of ice over the Arctic Ocean. That ice has been covering the Arctic Ocean for many hundreds of thousands of years. But because of the global warming now taking place, we've seen the loss of that thick chunk of ice floating on the Arctic Sea, slowly going down until now, during the polar summer, that is 3 months in the year, that is no longer covered with ice. Ice reflects sunlight away into space very effectively, and the blue sea absorbs it very effectively. It's 90% reflected by ice, 90% absorbed by the blue ocean. And so what is happening now is that the North Pole during the polar summer is now one of the warmest regions of the Northern Hemisphere. And when I say that, I have to quote my very good colleague, Tero Mustonen, who is a member of the Sami people who've lived on the ice for, they say, for thousands of years. I spoke to him in May, June this year. What's the local temperature? He said, it's pretty cold. It's -30. And I spoke to him again in July. Right? Not long afterwards, in July, he said, you're not going to believe it. We can hardly believe it. The temperature is now +32, a 62 degrees centigrade temperature rise in a few months. That's the arrival of the polar summer. The loss of that ice means the Arctic Sea gets warm very quickly, and the air above it gets warm, and the land masses around it are getting warm. And so in Siberia, northern Russia, the Vassal region, they have experienced remarkably high temperatures as well during the polar summer period. Sitting in the Arctic Sea during the polar summer is, of course, Greenland. So it's now sitting next to blue water sea, warm air. And when all of the ice has melted on Greenland, and counting for no other ice melting on land around the world, sea levels will have risen by 7.5 meters, by 23 feet. Right, so we know that, frankly, the game is up for us at well before we get to a 23-foot sea level rise. I'm sitting talking to you in Cambridge. It will only take 1 or 2 feet for us in Cambridge to express extreme flooding from the oceans. So we're looking at a very extreme situation. But there's another big danger in the Arctic Circle region. A vast amount of carbon is stored in the Arctic Circle region, and a good proportion of it is stored in permafrost. Permafrost is the frost that sits on top of land in northern Russia, northern Canada, northern Finland, etc. And the permafrost is now warming up rapidly for the reasons I've just given. And within the permafrost is methane hydrate, this molecule that methane combines with water to make. But methane hydrate is unstable at a temperature below the melting point of ice. And so methane is being emitted from that part of the world into our atmosphere. Methane is 100 times more serious per molecule as a greenhouse gas than carbon dioxide. So there's enough methane up there that when it's all into the atmosphere, global temperatures will rise by more than 20 degrees centigrade. Right, so well before we get there, we can forget our wonderful world. So Matthew, the point I'm making is we can happily look back 2,000-3,000 years. If you go into Greece or Turkey or any of these regions of the world, you'll see the buildings that our forebears put up at that point in time. And we have no chance of looking ahead more than several hundred years, let alone to the end of this century, if this carries on. So we need to get greenhouse gas levels down from where they are today to stop these tipping points going. The next one, there's a domino effect, and the next one may well go before we can refreeze the Arctic. We need to fix this as quickly as we can so that we can bring greenhouse gas levels down, so that we can leave the fossil fuel age behind and move away from emissions, right? So that's the reason why it's become imperative that we keep ice over the Arctic Ocean during the polar summer so that we reflect the sunlight back into space. There's another way you can reflect sunlight back into space, and that's with white clouds. And that's what we're looking at now as our main means of restoring ice over the Arctic Ocean during the polar 3-month summer period. And so what we are operating on is a simple mechanism of repeating what nature does. When there's a storm at sea, we create tiny droplets of water above the ocean, big waves splashing around, creating these droplets of water. The very smallest droplets of water are carried up by the atmosphere, by the wind going up. And in the upper atmosphere, they've lost on the journey up all of the water, and all you're left with is a tiny crystal of salt. And that tiny crystal of salt, when it's up there, will pick up, again, a small amount of water. It's not moving anymore. And that creates a white cloud. Now, a white cloud is composed of tiny droplets, so it's got to be tiny crystals of salt that have this effect. So what we're looking at is how we can pump seawater through a nebulizer, through a sieve, to create tiny droplets of water that are then picked up to create white cloud cover. When all of this is in operation, we would plan to surround the Arctic Circle with these vessels in the ocean. These are vessels driven remotely. There's no people on them, but we would operate the pumping of droplets when the meteorological offices tell us the wind is blowing towards the Arctic Ocean. So we see that we cover the Arctic Ocean with white clouds during those 3 months. We have to carry that on every year, once we've learned to do it. Is this expensive? It depends how you evaluate the cost. The running cost is likely to be, when it's in operation, all the vessels have been constructed, is likely to be £2 to £4 billion a year. Compare that with the loss and damage from rising sea levels, the loss of major cities that are due to go underwater at the way we're going today by mid-century. I'm not taking you to the end of the century, just 30 years' time.